Let us consider marginal and joint probability, and we normally use what we refer to as the contingency table. An example, the table shows political registration of 200 residents in state X. So what we have is the gender, male and female, and then the party, it's a Democrat, Republican, or Independent. 35 of the male out of the 200 people are in the Democrat, and 45 of the female are in the Democrat. The Republican male is 47 and female is 33. The Independent, 25 male and 15 female. So the letter D is for Democrat, letter R for Republican, I for Independent, M for male, and F for female. So we want to do a few things. What is on the margin, what is on the outside is what we refer to as the marginals. So the marginal is the values that are on the edge. So if I start off with the marginal probability, the marginal probabilities will be the ones on the outside. And what do I mean on the outside? For example, probability of a male is 107 over 200. Probability of the female will be 93 over 200. And if you sum these two, they should give you a probability of 1 for the gender. The marginal for the party, probability of a Democrat is 80 over 200. The probability of the Republican is 80 over 200. And the probability of an independent candidate is 40 over 200. So when you sum those three again, they should give you a total of 1. So the values on the outside, where the total is, that gives you the marginal. But now the values on the inside, 35, 45, 47, 33, 25, and 15, are what we call the joint. Why is it joint and these are marginal? These are individuals. This is male only, this is female, this is D, this is R, and this is I. But for these values that we have inside, for example, 35 is the intersection between being a male and being a Democrat. 47 is the intersection between being a male and a Republican, and 25 is being a male and an independent. So that's why they are joint. So, and that's where we use the intersection. So the second category is what we call the joint probabilities. The joint probabilities. And one of them is the probability of a male and a Democrat, which you can also write as the probability of a Democrat intersection a male, and that will be equals to 35 all over 200. Then we have the probability of a male intersection Republican, and what is the value? It is 47 over 200. And also we have the probability of a male intersection I, and they are 25 over 200. So these are all what we refer to as joint probabilities. I can also look at the female intersection D. There are 45 females who are in Democrat. Probability of female intersection Republican, how many are they? They are 33 over 200. And then probability of female intersection I will be equals to 15 all over 200. Now the beautiful part is if you sum all these together, 1, 2, 3, 4, 5, 6, the total should be equals to 1. So all the values inside there in the joint distribution should be equals to 1. Probability of Democrat, given that it's a male, is the probability of Democrat intersection male all over probability of a male. And we know a Democrat and a male is 35 over 200 divided by the probability of a male is 107 over 200, and the answer will be 35 over 107. That should be the probability that it's a Democrat given that it's a male, and the probability is 0.327. So probability of female given I will be probability of F intersection I all over probability of I. And we know that the probability that is a female and they are independent is 15 over 200. And the probability of being independent is 40 over 200, which is 15 over 40, which is 3 over 8, alternatively 0.375. So you can leave it as a fraction or as a decimal point. That will be equals to probability of female plus probability of Republican minus probability of female intersection Republican. And this, the probability of a female is 93 over 200. Probability of being a Republican is 80 over 200. And the probability of a Republican and female is 33 over 200. So this will be equals to 93 minus that 3 is 60. 60 is equals to 140 over 200 by 27 by 2010, which is 0.7. So what does that mean? You are either picking a Republican or you are picking a female. Now, those who are Republicans, irrespective of being male or female, they are 80. Those who are female, they are 93. So if you add those, you get 173. But now, remember that there is where the Republican and the female intersect. So those values are counted twice. And that's why we are subtracting one of them from the intersection. So that will give us the probability. So with a contingency table, you can be able to calculate the marginal probabilities. You can be able to calculate the joint probabilities and also the conditional probabilities. So I will say it again, we have used this formula because they are not mutually exclusive. They are not mutually exclusive, and that's why we have used that formula. I'm sure you love these videos. Please continue watching and do subscribe. Thank you.